Hello, everyone. Today, we will walk you through the slow SQL diagnosis feature of GaussDB. Let's break it down into three parts. In the early stages of database development, data volumes were modest and workloads were relatively straightforward. Operations and maintenance relied heavily on manual processes, placing significant demands on the expertise of database administrators. As data grew and systems became more complex, manual O&M began to show its limitations, making it increasingly difficult to ensure efficient and stable data management. To improve efficiency and reduce operational costs, automation has become a core strategy in modern database operations. With scripts and automation tools, routine tasks like installation and configuration can be executed automatically. This not only shortens deployment time, but also ensures consistency and accuracy. Some organizations have gone further, building integrated automation platforms that manage the entire database lifecycle, from provisioning and deployment to monitoring, maintenance, and decommissioning, through a unified interface. This shift has significantly improved operational efficiency and control. Now, with the rise of AI, we're entering the era of intelligent O&M. By harnessing machine learning, deep learning, and big data analytics, intelligent systems enable capabilities such as performance prediction, automated fault detection, root cause analysis, and policy optimization. For example, models trained on historical performance data can proactively identify potential bottlenecks, giving DBAs early warnings and time to respond. In the event of a failure, intelligent diagnostics can analyze logs, metrics, and system states in real time to pinpoint the root cause and even suggest solutions, significantly reducing recovery time. This evolution from reactive to proactive operations marks a major leap forward in database management, boosting efficiency, enhancing reliability, and reducing both cost and risk. Now let's take a closer look at GaussDB's intelligent, slow SQL diagnosis feature. GaussDB provides a one-stop solution for identifying and optimizing slow SQL queries. With a single click, developers can access comprehensive diagnostics, including execution time distribution, SQL text, execution plans, SQL patches, and more. Once slow SQL statements are detected, GaussDB offers a full suite of optimization tools, including root cause analysis, SQL throttling, execution plan binding, index recommendations, and SQL patching, all integrated into a unified workflow that simplifies performance tuning. This feature stands out for two key strengths. The first is fast troubleshooting. GaussDB supports multiple data collection methods, enabling fast and accurate identification of problematic SQL statements. The second is high efficiency. Its trace analysis engine delivers actionable optimization suggestions, significantly boosting operational efficiency. GaussDB uses a hybrid offline-online approach to diagnose slow SQL queries. It begins by collecting potential slow SQL query scenarios, capturing SQL text, execution time, scanned and returned row counts, alongside key metrics from the database, operating system, and resource usage. These data points are used to train an offline model, forming a comprehensive slow SQL feature library. So what's the role of this feature library? When a slow query shows up in production, GaussDB leverages the library and applies a KNN algorithm for real-time inference. It identifies the root cause and provides targeted optimization suggestions. The slow SQL data collection and analysis process consists of four key components. First, acquisition of application SQL statements. Slow SQL data is retrieved from the statement history system view, which includes SQL text, execution timestamps, row counts, and other relevant details. Second, acquisition of key slow SQL metrics. These metrics reflect the execution state of slow SQL statements and fall into two categories: database-level metrics and system-level metrics. Database-level metrics, such as number of returned rows and index usage, are sourced from system catalogs and views. System-level metrics are collected directly from the operating system. The third component is feature construction. GaussDB builds feature vectors based on the collected metrics to support root cause analysis. For example, Comparing returned rows to scanned rows can reveal whether a slow SQL query involves a large scan. The fourth one is feature weighting. GaussDB uses KNN to identify the top K historical cases whose feature vectors closely resemble those of the current slow SQL and applies majority voting to determine the final root cause category. Next, let's explore 4 examples of how to use GaussDB's slow SQL diagnosis feature. Let's begin with a practical example, viewing slow SQL data in GaussDB. GaussDB enables you to identify slow queries with a single click. You can customize filter conditions, such as the execution time range SQL keywords to collect. For example, select exclusion of system users and duration threshold to narrow down the results. The diagnostic output includes normalized SQL ID, node name and ID, username, SQL text, execution plan, number of slow query executions, average execution time, CPU and I/O time, rows returned and scanned, buffer hit rate, and more. These metrics help pinpoint performance bottlenecks and guide effective query optimization. As shown on the screen, you can instantly retrieve all SQL statements with execution times exceeding 10 milliseconds and examine their detailed metrics to identify optimization opportunities. Another powerful capability in GaussDB is the ability to view top SQL statements. GaussDB can highlight the most frequently executed SQL statements over a specified time period. Like the slow SQL feature, it provides rich diagnostic data, including normalized SQL ID, node name and ID, username, SQL text, invocation frequency, CPU and I/O overhead ratios, number of calls, tuples returned and read, total and average execution time, minimum and maximum durations, and SQL hit rate. This helps you identify high-impact queries and prioritize optimization efforts. Let's continue with SQL Explorer, a feature that records all SQL statements executed within a defined time window. To use SQL Explorer, you first need to enable it and configure the relevant collection parameters. SQL Explorer collects and stores all SQL statements executed on your GaussDB instance. This allows you to review SQL statement metrics, execution details, and other related information. SQL Explorer supports instance-level configuration, offering flexible options such as filtering out system users, setting default data retention periods, and specifying which SQL keywords to collect. This makes it easy to tailor the logging behavior to suit different operational needs. Additionally, GaussDB provides table definition lookup. You can extract table names directly from SQL text and query their definitions based on table name, schema, or database, enabling deeper insight into query structure and schema relationships. Finally, GaussDB includes a SQL throttling mechanism to manage abnormal query behavior. When there are abnormal SQL statements, for example, poor indexing or the number of concurrent SQL requests increases, you can apply throttling policies on the page shown on the screen to control query load and maintain service availability. For example, when SQL concurrency increases, you can limit CPU usage, memory usage, and concurrent query count at the instance level. Once the problematic SQL is resolved, throttling can be lifted to restore full service capacity. That's all about GaussDB's slow SQL diagnosis. We hope you find this video helpful. You can visit our help center to learn more.